Before troubleshooting, confirm the equipment identity from its nameplate and documentation. A whole house fan pulls outdoor air through intentionally opened windows and exhausts the house into the attic. It is not an attic ventilator or an HVAC blower. Record the model, controller, and installed arrangement before assuming any fault. Never run this fan with the building closed. Open the required windows or other approved intakes, and confirm that the attic has the designed exhaust path. A blocked intake or attic outlet can create excessive pressure, noise, shutter problems, and poor airflow even when the motor is healthy. Treat combustion safety as a hard gate. If fuel-burning appliances are present, or you notice a carbon monoxide alarm, soot, smoke, flame disturbance, gas odor, dizziness, or unusual depressurization, stop. Move to safety and use qualified combustion and ventilation assessment before operating the fan again. A homeowner can make external observations without entering the attic or removing guards. Note whether the controller displays power, whether a command is accepted, whether shutters move, and whether the fan is silent, humming, cycling, or producing airflow. Do not reach through a grill or force a shutter. An off switch is not electrical isolation. Whole house fans may have timers, thermostats, relays, remote controls, or automatic restart logic. A qualified person must identify every supply, isolate it, lock it against restart where required, and verify the safe state before opening equipment. Attic access is a separate safety decision. Heat, poor footing, low clearances, insulation, electrical hazards, contaminants, and falls can make a routine check unsafe. If the fan, control box, belt, or wiring cannot be inspected from a stable authorized location, stop and use qualified service. Large blades, belts, pulleys, and shutters retain motion and can start unexpectedly. Never test with a guard removed, never handspin through an opening, and never defeat an interlock. A brief hum is not permission to keep energizing a stalled motor because heat and stored electrical energy may increase. Use a layered fault tree. First verify building air paths and the exact operating command. Then a qualified technician verifies supply and control output, safety devices and interlocks, shutter freedom, belt and wheel condition, capacitor wear fitted, motor condition, and obstruction or overload. Each result determines the next test. With all energy sources isolated and stored energy handled, inspect for a displaced belt, loose hardware, rubbed wiring, seized bearings, damaged shutters, debris, water, overheating, or an obstructed wheel. Do not bypass a control or connect mains directly to prove a motor. Document evidence before replacing parts. Replacement parts must match the documented electrical and mechanical requirements. Voltage, frequency, phase, speed, capacitor value, rotation, mounting, belt geometry, thermal protection, controller compatibility, and environmental rating can all matter. Similar appearance is not an engineering match. Remember that the airflow path is part of the load. Closed windows, insect screens, restrictive grills, blocked attic vents, stuck dampers, and added air sealing can change pressure and motor loading. Correct the building level restriction rather than treating the motor as the only suspect. Commission only with every guard, cover, shutter, and access panel restored. Reopen the specified intakes, verify smooth start and stable airflow, check vibration, noise, temperature, controls, and shutdown, then confirm building pressure and combustion safety where applicable. Record the final configuration and measured observations.